Hi girls, oblique planes 6. So again, you're getting this particular slide from the oblique planes PowerPoint, and it is the one that says oblique planes 6 on it. Of all of the oblique planes questions and examples that I do, this particular one is probably one of the most important ones as regards a revision sheet. Okay, so this one in particular is one that you will use quite a bit just to refer to, and it's one that I go back on quite a few times just in explaining it again. Because the first question here on the left is when you have the vertical and horizontal trace and you have to find the cut shape, try and get the true shape and everything. Whereas the second one, you have the cut shape and you do not have the vertical VTH, or the vertical and horizontal traces, which means there's a little bit more work involved in it. So it's a question that, or two questions that look at both ways that the question can come up. So when you have the VTH, you're using the 5 or 6 point, whatever many points, you label them if you wish. And I want to find those 5 points up in elevation. So this is lines 1 and 2, this is lines 3 and 5, and the last line is line 4. As you would have seen from every other question that we've done so far, if you want to find a point up in elevation or in any other view, all you're doing is bringing the point up parallel to the HT. You're then going to bring it up vertical, and you're then going to transfer it across. Okay, so they are actually in line, and these two guys are also in line. Just going to get my T-square now. So I've brought up all 5 points. You can see that 2 of them happen to be in line with each other. I'm going to bring each one up till it touches the vertical trace. And then when it does touch the vertical trace, I'm just going to highlight those points. So 2 touches here. I can bring it across to the line 2 and find where 2 is going to be up in elevation. So there is 1 vertex. I can do the same with 1 and 2. 1 and 3 is my next one. Stops here on the vertical trace, so that's the height. Bring it across to the lines 1 and 3. 3 being here and 1 being there. And the last one then was 4 and 5 for me. I brought it up, saw where it touched the ground, brought it up vertical, and saw where it is touching the vertical trace, which happens to be on a same point you already have. And you're going to bring it across to the correct line and find it on the relevant lines. So that was 4 and 5. So 4 and 5 is this height. So you'll find 4 and 5 at the same time. When you are finished, you're just going to transfer these points across and finish off the shape. Join 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 5 back to 1. Okay, now that the top has been cut off and we've got the cut surface on top, we can just continue on the edges as they will appear heavy or light, or both. So as you can see, the elevation and plan are fully complete. Okay, so normally part 1 of the question is complete elevation. And other questions you could be asked on this is get true shape or get true angle. And the angle depends on the question. So it could be the true angle to the horizontal trace or the true angle to the vertical trace. In this one, I want to get the true angle to the HT. So to the horizontal plane or to the horizontal trace. Now I know mine is going to actually cut into that, so I'm just going to rub those out because it's actually in the way of doing that auxiliary. But that's usually the 2 types of questions that you can be asked. So as you would have seen, if you want to get the true shape, you have to eliminate one of the angles. So eliminate one of the oblique angles to turn the entire drawing into a simply inclined plane, because that's what you would have dealt with in second and third year, is you'd create a simply inclined plane. So to get rid of one of the angles, the easiest one to always do is look along the HT, and that gets rid of that angle. And it changes this plane into a what is it called? Simply inclined plane. So you can see here, I've created 90 degrees to the HT, and this becomes my new X1, Y1, so my new ground line. Okay, the process is to get the angle, so the angle that this vertical trace is actually at, you're going to take any point along the ground here and bring it out into the view. So I could choose this one or this one or this one or this one or this one. But I would always say to you, draw a vertical line that's tall enough for you to measure it with your compass. So that's all I'm going to do here now, just in a different colour. So I'm just creating a new height line. And the point I'm going to bring out is the point on the ground that I want to find out in the auxiliary. So again, sliding your set squares parallel to the HT, bring out that point that's on the ground, and all we're going to do is take this height and transfer it, and that changes the angle, and it gets a true angle of the vertical plane to the horizontal. Yes, we're taking the height, transferring it into the new line, new position. So that height is actually here. And it's got a point, okay, it's got that point on the vertical trace, and the vertical trace is joined back to the XY line. So this is my XY line where it started, and this creates the angle. So that is my vertical, sorry, you can't actually see that, I'm gonna just move it up, vertical and horizontal trace, VHT or VTH, doesn't really matter what way you do it. Okay, now that I have my cut surface and my simply inclined plane done, I'm going to redraw out the prism out in the auxiliary. So at the minute I'm doing an elevation, and when you do an elevation you need to take all the points from the plan. So because I'm looking along the HT there, it's points on the plan that I need to bring out. So bringing out 2, 1 and 3, 4 and 5. And when you do an auxiliary, you always work from your last XY line back. So this is my new XY line. Okay, and I'm taking it from this drawing. My last XY line was here, and back is actually heights that I'm taking, and that's why I was able to take that height and transfer it. But I can take the heights of all of those points. I'm going to take the height of the original prism. That's all I really need. On any of those lines, it doesn't matter which line I take. And I'm just transferring the height of the prism over. And where the prism is actually being cut is from here down, they will be heavy lines. So from the vertical trace down to the ground, that is where your solid actually is at a true angle. Okay, and I'm just going to draw in that angle. Okay, I'm going to call it alpha, it doesn't really matter. But that angle is a true angle to the horizontal plane. And that angle for me is like, it's 44 degrees, but it's probably meant to be 45 because I traced this. I might be a little bit off, but on mine it's 44 degrees. In an exam, it's always plus or minus 5 degrees. So let's say the true angle is actually 45 degrees. If you got 48 degrees or if you got 43 degrees, it's all perfect. Okay, because it's plus or minus 5 degrees from the actual number itself. So even 40, anything from 40 to 50 will be fine. Now, as you would have seen from junior cert now, this is what you would normally have seen. We're going to rebat the surface around, bring it down, and we'll get the true shape down here. Apologies. Okay. So get your compass. Compass goes on the HT, and you're going to rebat, which means knock down flat or kind of turn it with your compass. Turn all of those 5 points, which just appears to be 3 lines, but it's actually 5 points it relates to. And I'll explain why in a second. Well, some of you probably already realise. So this is 4 and 5. So when I brought it around, there is 4 and 5. The next one was 1 and 3. And you rebatted it around, and there is 1 and 3. And the last one was 2. And you rebatted it around, and there it is. Okay, so it's the opposite way around. You're then going to bring back those 5 points into the plan as such. So we're going to bring all of those points down. Sorry, now my board is kind of slipping on me for some reason. Okay, so bringing down 2, bringing down 1 and 3, and bringing out 4 and 5. And when you bring your points from the plan out to this view, it needs to come perpendicular to the HT. And you can slide or flip your set squares. I flip them, as you can see. So I'm bringing out 3, I'm bringing out 4, I'm bringing out 2, I'm bringing out 5, and I'm bringing out 1. And I'm going to find them on the relevant lines. So 1 is here, and this is 1, so that's the point 1. 5 and 5 is out here. 2 and 2 is on this center line. The next line is 4, which is also on the line 4, so 4 and 4. And then finally 3, and line 3 is here. So now that you have all 5 points, you can just join them together, and this gets the true shape of that cut surface. Again, this part you have done a good few times before, and you would have done it in junior cert. It's just that your page would have been completely slanted, as if it was like a normal elevation and a normal plan, and you're rebatting it around. But we had to do an auxiliary in order to achieve that simply inclined plane first. And that's kind of the only real difference with the oblique plane and the simply inclined plane. You change the oblique plane into a simply inclined plane, and then you're able to work with it. So what I have here is the true shape. In this view, I have a true angle. I also have true heights here, so like that's a true height, this is a true height, and so on. So I'm just going to show you here now. Sometimes you could, if you worked from the plan, you could do the auxiliary and you could take the heights from the auxiliary and transfer it. That's the second way of doing it. That you wouldn't have to slide all these parallel and bring them up to the vertical trace and across. What you could do to get this shape is you could have done the auxiliary to start it off, but like the height of 4 and 5 is this height. And you can transfer it there and you can see it's the exact same height. You could go over here to the points 1 and 3, transfer that height. 1 onto the line 1 and 3 onto the line 3, and you can see that they're the exact same heights, and that just proves that this is the correct angle that I've found. So that is the first question done. Sometimes you might be asked, I think in this question you could have put a star on the true surface, on the true shape, and you had to find it in plan and elevation. So you could draw a star on that shape by drawing a pentagon, that is, and joining all the vertices of the pentagon to get the star, which you would have done in second year, first year even. You could rotate it backwards into plan and up into elevation. We might do that when we come back into school, but for the moment this drawing is actually quite small. I'd need to do it on bigger paper just because accuracy and that kind of thing. So that's question 1 done. This is question 2. In this question, we have the cut surface, we have the shape. What we don't have is the vertical and horizontal traces. Now, in order to get this, usually we need points on the ground to get a horizontal trace. What I mean by a horizontal trace, I'm just going to use a book to explain it. So this thing is now sloped, and I'm standing it up. And you can see I have 2 points on the ground, and that creates a horizontal trace where it cuts on the ground. The problem with all of these 5 points is none of them is on the ground. So you don't have 2 points to join to in order to get the horizontal trace. When you're faced with a question that doesn't have the oblique plane drawn in for you, the easiest thing to do is find the 2 points on the ground first. And then you're going to use your cut shape in order to get a point on the vertical trace. Now, you can imagine that's your flat surface, but if there's an imaginary plane, you know a plane is an infinite length in all directions. So although it appears not to be touching the ground, if you had a flat surface, I'm just going to draw on this, maybe on the back. I have kind of like a pentagon shape drawn on that surface. Okay, so what you're looking at is the elevation of it, but that surface is on a plane which is a flat surface, and that could continue on down to the ground, and we're going to get 2 points on the ground in order to draw the horizontal trace. So just with this, if I want to find points on the ground, I'm first of all going to label all of the points on the drawing so I won't get confused later on. So basically I'm going to go 1, 2, 3, 4, 5. So I know this one up here is 3. The one at the back here, that's 4. This is 2. That is 1. And this is 5. I'm going to draw lines on this surface that will find points that touch on the ground. I'm going to explain this again using colours. So I'll take maybe 2 or 3 different colours. Grand. Now, basically what I'm saying is I need to draw lines that are going to force them to touch the ground. If I joined 3 to 4 and I connected it in each direction, it's never going to touch the ground. If I join 2 to 5, they'll never touch the ground because it's a horizontal line. However, you can see if I joined 3 to 2 and extended it on, it will touch the ground. Equally, if I join 3 to 1 and extended it on, it will touch the ground. 1 to 4, extended, it will touch the ground. 3 to 5, extended, it will touch the ground, and so on. So if I do maybe 2 or 3 lines, even 2 lines is perfect to draw a line. So if I have 2 points, if you join 2 points together, you'll get a line which will be the horizontal trace. So I'll do 1 to 3. I'm going to join 1 to 3. But I'm going to continue it on until it does touch the ground, because in order to draw the horizontal trace, I need a point on the ground. So there's 1 point on the ground. And you know from doing maths or anything, whatever you do on one side of an equation, you have to do on the other side of the equation. So I have joined 3 to 1 in elevation. I need to join 3 to 1 in plan and extend it on like I did earlier on. To find where this point is, if I just bring it down like I always do, I'll find it in plan. And I'm going to do this one last time. Then I will have 2 points and I'll get the HT straight away. So I'm just going to bring that point directly down. And obviously that point then has to be a point on the ground. So now that I have 1 point on the horizontal trace, if I find a second point on the horizontal trace, I've done enough and I can draw the horizontal trace in. So as I explained, joining 4 to 3 is no good. Joining 2 to 5 is no good. Okay, so basically I could join 3 to 5 and extend it on. I could do 2 to 1 and extend it on. 3 to 2 and extend it on. The reason I'm kind of hesitant to do 4 to 2 or 3 to 2 or even 2 to 1, it's all very close together. You can see that this line here is just, it's pushing it away from the close contacts, and it's a little bit easier for you to see. You can see my ground line isn't long enough. I'm just going to extend it. Okay. I have found where 3 and 5 touch the ground. I've drawn a line in elevation from 3 to 5 and I've made it longer. Well, I do the same in plan. Join 3 to 5 and make it longer. To find where it is now, I'll just bring this point down, directly down, and where that point touches, that is a second point on the horizontal trace. I brought it straight down, there it is. So I have 2 points on the horizontal trace. If I join them together, I can get the HT. I'm just going to prove this with a different line. I might go 3 to 2 because it's not very close to line 1 and 2. So I could do 3 and 2 together and extend it on till it touches the ground. Then I could do 3 and 2 together and extend it on in plan. Maybe that's not long enough now. I'm just going to make that a little bit longer. And again, I'm going to bring this point that is on the ground down vertical and I'll find it in plan. And then guess what? I'll have a third point on the horizontal trace. If I'm accurate, all of those 3 points should be on the same line. So yeah, a little bit off. But yes, you can pretty much see that they are all on the same line. Bar that one there, it's a little bit off. Could have been just my setup. But if you take 2 points, it should be enough to get your HT, and you can just label it HT. In order to get any other point on the vertical trace then, you do what you did to find points on the actual cut surface. So because we have the points on the cut surface, we're going to work backwards. So I'm going to take 3 and 4 maybe, because 3 and 4 are the highest points on the drawing. Okay, I've found where it touches on the ground. I'm going to bring it up. And usually you bring it up till it touches on your VT, but we don't know exactly where that is. But I'm just going to refer you back to this. Normally bring it straight up till it touches on your VT and then bring it across till it touches on the line 4. Okay, but now I have the line 0.4 already. So if I just bring it across to meet it, that has to be a point on the VT. And I have a second point on the VT. If I join them together, I have the VT found. So that's the vertical trace and the horizontal trace found. What you could do with this then is you could look along this, get the true angle, rebat it around, bring it down, and you get the true shape, like we did with this question. But the biggest learning on this one is when you have the cut surface and you're looking for the VTH. What you do is extend lines on the surface. This is what we did. We extended lines on the surface till they touched the ground and repeated this in plan. Extend lines, and you need to take this down because it's not in the notes anywhere. So extend lines on the surface and repeat in plan. When I explained what lines and points and planes are, in order to draw a line, you needed 2 points on the surface or on the line in order to draw a line, so 2 at least. So you need to do this twice. When you do it twice, you get 2 points. And this is your HT. Once you have the HT, getting the VT is very simple because I could choose point 1, come parallel to it, bring it up and 1 across to meet it, and I'll get another point on the VT. I could bring 2 up, vertically up, and bring 2 and 5 across to meet it, and I'll get another point on the VT. But if you could do like the 5 of them if you wanted, then you should get 5 points in a line. But it depends, obviously. If it's a printed drawing, you should have no problem. They should be all definitely in line. But because I traced mine, my sheet could have moved ever so slightly, and that's why that one is ever so slightly off. But I just chose the best fitting angle in between. The only variant I would have is if I got the true angle, like I did over here, that 44 degrees, this could be a good bit out. Well, it could be not within the 5 degree variant, simply because it wasn't accurately drawn in the first place. But normally when you're drawing something, you're doing it on a bigger sheet, it just makes it a little bit easier. But that's the main learning on oblique planes. So transferring points, getting true angles, and then getting true shapes. That's basically it. Then working backwards, when you have the cut surface or you have the true shape, and then finding the VTH. That's the second thing that you might be asked to do it. So this is oblique plane 6, one of the most important learning sheets for you in this whole topic. We'll start doing exam questions now and start implementing these 2 different things in it, just so you know how to see it in action in a proper question. So these questions were started for you. All you have to do is finish them. In the next few questions that we're going to do, you will have to actually do it all out from scratch. Okay?